Bambu Lab is a company most of you have never heard of, making a product most of you have never used. But we picked this company anyways because they happen to be one of the fastest growing hardware companies on earth. They went from zero to undisputed market leader and from zero to multi-billion-dollar valuation, both within the span of 5 short years. What Bambu Lab makes is desktop 3D printers. Before they released their first product in 2022, the entire industry assumed at-home 3D printing was destined to stay a fringe hobbyist niche, that everyday people just weren't interested. Bambu's founders didn't buy that. They blamed the product instead. They believed that the hardware itself was broken. While everyone in the industry, even the users themselves, accepted that 3D printing would always be slow and somewhat unreliable, Bambu saw this as a massive opportunity. And it turns out they were absolutely right. They applied precision robotics to turn 3D printing into a push-button appliance, offering consumers a combination of fast printing speeds, zero friction setup, and rock-solid reliability. They easily won over the experienced users while also attracting a huge number of new buyers, growing the market far beyond anyone's expectations. The reward is a total domination of an industry, almost overnight. In this episode, we're breaking down who they are, exactly how they did it, but also the fierce challenges they're now facing as the new incumbent market leader. I'm Linda.
And I'm Pan.
And welcome to another episode of Ascent. Let's start with who are the founders and how did they meet each other?
All right, on to chapter 1. Before Bambu Lab is Bambu Lab. This is always how we started. So the first person that is of particular interest, Dr. TAO Ye, or Dr. Tao, let's just call him that way. Or later on, as people from DJI would call him, Dr. Turbo. But let's go back to Dr. Tao.
Really?
Yeah. Without Dr. Tao, none of it would happen. And for some reason, I guess, he probably had his information removed on a lot of websites, which is why you cannot find his exact birthday. He entered college at the age of 16, and somehow I have him on LinkedIn, though I've never chatted with him officially. But if you add up the math, he would be born in 1986, and he was born in the countryside of China. And rumor has it that the places that he was growing up in had a bamboo forest. He had a jolly childhood. That is pretty much it. And at the age of 16, he entered the University of Science and Technology of China, USTC, to study astrophysics. And he did a brief exchange to HKU of Science and Technology in 2005. You know, in some universities in China, they take young genius kid as the age of 16, not 18. And he was one of those young genius kid who started college at the age of 16. And typically, you have to have a very strong suit in STEM majors to be able to qualify to that kind of universities. And after undergrad, he then received a master/PhD degree in fluid dynamics, which is astrophysics and more 3D modeling, in Jacobs University Bremen, Germany, where he won an Outstanding Student Presentation Award from the American Geophysical Union. And very interesting quick plug, you know, Jacobs University in Bremen, which is no longer the name of that school, is currently called the Constructor University.
Oh, what?
Yeah,
it's a STEM kind of mechanical engineering type of...
It is, well, yes, it is. It is an international and private and residential university located in Germany. Offers a variety of subjects, but mostly engineering. It kind of is the private university that really champions the sort of the maker society and, you know, tinker around. And it has a lot of international students. More than 80% of the students are foreign students.
That's a lot.
That's a lot.
Yeah.
Well, it received students from more than 100 countries. Dr. Tao graduated PhD there, and at the year 2012, he then went to DJI to become a sort of a scientist turned engineer because he believes that he is a lifelong maker. And I try to look for different sources and piecing together the information to get a sense of, at the age of, 20 something, 2012, you're graduated. How could you possibly find DJI at the time?
Well, first of all, what is DJI?
DJI is likely the number one consumer level drone camera company in the world. We will probably cover the whole story in a different episode. Dr. Tao didn't start with Bambu Lab. He started with DJI.
Yeah, he's actually a latecomer to the 3D printing industry.
Yeah, he's a super latecomer, but
but DJI, we'll definitely cover this in another episode, but legendary company that started in China, not only dominated the industry, I think they actually propelled the industry to what it is today.
Absolutely. So Dr. Tao only ever worked for two companies his whole life. One is DJI and the other one is Bambu Lab.
Lucky him.
Yeah, lucky him. 2012 is the time that DJI is still quite small, less than 100 people. DJI founded in 2006. And by the time, DJI was the only super well-known hardware company that is taking form in Shenzhen. So there is a fair possibility that the founder of DJI, Wang Tao Frank, interviewed Dr. Tao himself. And both of them have a lot of sort of tinker, maker spirit in them.
Yes.
Hit it off, decided to work together.
So he joined a promising startup-ish. Like not a global company as of today.
Not at all. Mm-hmm. He joined a
mid-sized.
A
mid-sized company with a lot of potential, but no one really at 2012 saw what DJI it is as today.
Right.
Yes.
Because, what he has done after he had joined DJI became a true milestone for DJI and made him who he is today, and also made DJI who DJI is today, the drone camera.
So what is his trajectory?
All right. So Dr. Tao entered DJI in 2012. His early strength was quite directly what he had studied, aerodynamics and motor design. So he started off 2012 in DJI as just an engineer and started working on drones. But drones back then didn't look like the drones that we have today, drone cameras. It looked more like this. Let me show you. A mini helicopter. It's not even a mini helicopter. It's quite big, to be honest. That's the first generation of DJI drone camera as a real shrinked size helicopter.
It's bigger than what we're seeing today.
Right.
It doesn't look like it's that foldable.
But it's four-legged.
And
Very different. Stands.
Very different.
Yeah. It's more like a mini helicopter, four-legged, has a platform, carries a camera. So that's the first generation of DJI camera that when Tao Ye joined. So he started working on drones, and 2012 to 2014, DJI has shipped this one product that's called Phantom 1, which is the four-legged one that we looked at. As Dr. Tao moved on with the project, he started to working on something that's more interesting because he realized that, but this is not convenient though. How do I make this as you said, one button, one push ready product? And that is easier for everyone to use. So from 2014 to 2016, he gets put on a different project. And that project is called Mavic.
It's still in the market today.
It's still in the market today, yeah. Maybe it's called Mavic 2 or Mavic Pro.
Yes.
But Mavic is the one that changed everyone's life. And Mavic was the camera that got really famous. And Mavic already looked like this.
Which is kind of what we're seeing in DJI shops today.
Yes, it is a boxy, small pack that extends and can fly and can navigate and can take photos. So that was Mavic.
So did Dr. Tao actually changed the whole product direction of DJI, and therefore you can actually attribute him to the ultimate success of DJI.
Let me just quickly walk through his whole trajectory in DJI, and then we'll come back to that. 2016 to 2019, because of Project Mavic, Dr. Tao then immediately get promoted to senior product manager and gets to work on Mavic 2. And Mavic 2 was launched later on with Hasselblad camera reinforcement, and then he was then directly promoted to the director of the whole department. 2019 to 2020, he was continuously working on the newer generations of Mavic. That's also the time that he left the company. So he left the company at a high point. He didn't leave the company as, like DJI is shrinking. Not necessarily that. Dr. Tao has one specific design logic, I think, answer the question that you just had, which was the sort of the King Midas touch of consumer electronics that turned a four-legged mini helicopter into a small mainstream product, which is he realized that average consumer will not try to use a scrappy product that breaks easily and is not convenient for repetitive use.
That sounds so familiar
That
for
sounds
3D printing.
The question becomes, as a good product manager, how can you make any consumer electronics unbox ready and plug and play, basically?
Of course, that's what consumers want.
Right. So while he was designing Mavic with the rest of his team, the question was, can this drone fly right out of your box as you open,
like
your new
literally when
package?
you unpack it, you can
It
fly
flies
it out.
So that was, as a hardware product manager, he is really obsessed with, I just want to make it very convenient for everyone. If we want to design this, then we need to design it. We need to really think about how do we make it into a flagship product, not shrinking the product, not making it cheaper, but to redesign completely that fits the customer's need. He's a really good product manager.
I think it's a very simple concept, right? If you're a product manager, design your product based on consumer wants and needs. But in reality, there's so much things to consider, especially in hardware development, that actually sticking by this rule and making all the decisions based on this rule is very
Excellent
hard.
point. That's a really good point. In DJI, they really champion an idea of, if you want to be one of the best in hardware product management, then you have to go through the DJI School of Training, because
Is that an actual phrase, DJI School of Training?
they have the DJI talent formula. Should you have these 4 skill sets, you will be able to dominate the hardware market. For whatever hardware that you create, you have to, as a hardware talent, you have to have the 4. And which is why DJI itself has spun off so many other hardware companies, right?
The employees of DJI who left and
Exactly.
took these 4, what you call it, the 4
The talent formula for
talent
DJI.
formula
Yeah.
outside.
And people call it, if you were to be in DJI for 1 year, it will be the equivalent of 3 years somewhere else.
Are you just working over or overtime every
That too, but here's the formula. Let's hear it out. So
Let's hear it out.
Number one thing is, you can't just be a single subject matter hardware engineer. You have to be a full stack hardware engineer, which is kind of a new idea. With that, you need to understand the science behind it, the software behind it, the commercial GTM, and supply chain. And you personally will have to glue everything together. That's number one. That's only number one. And number 2 is, you need to be able to build every product in mind with the full commercialization cycles that comes after that. Number 2. You can't just build it.
It's a lot of work already.
It's a lot of work.
Yeah.
Number 2, if you build something and can't sell it, that's a failed product, failed consumer product, right? Number 3 is, you need to understand the supply chain. Okay, fun fact, DJI is started in Shenzhen, which is kind of the heart of supply chain within China. So understanding the supply chain is a must. And last bit, number 4, if you want to be a DJI engineering talent, then you have to be obsessed with using upon unboxing. Otherwise, everyday user will not use your product every day.
That's the most important one. So then if he's so successful in DJI, why did he leave?
In 2020, Mavic has already proved that it is a sellable product. It's doing very well.
Yeah.
And so, of course, as a maker, also as an excellent engineer, TAO Ye proposed in one of the meetings, and obviously this proposal is not just off of his head, he's thought about this. He had actually been discussing with other fellow engineers for a while that maybe 3D printing would be a good idea. And this is 1 year in advance. And so they are starting to pitching that idea within the company. And he claimed in one of the news articles that I've read, said within 5 minutes of that ideation, pitching and meeting, it was vetoed. It wasn't deemed to be a sustainable product because everyone is rushing to the bottom in terms of price. And it's very hard to use any current product in 3D printing at the time. And this is 2019.
That is so wrong if we think about it.
But nowadays. It is also very true. It reflects the, if
the market at the time, the sentiment at the time.
So his ideas got shut down and he wasn't very happy. And so that's when he started, he didn't obviously leave the job, but it got him thinking. It got him thinking that, oh, I still do think this is a very good idea. And I really want to be making this. What do I do? And before, I guess, we move on to the next segment, I just wanted to point out one thing. Leaving DJI obviously is not an uncommon thing to do. You would think that, oh, is Bambu Lab the first company that, left DJI? There are actually 24, more than 12 of companies.
That's a very long list.
That's a very long list of companies who have left DJI before. All the way starting from 2014, there were robotics company, there were battery company, there were different drone companies. Bambu Lab was the first 3D printing company that had spun off from DJI.
Very interesting. Yeah. Because it's not like the spun-offs are all drone related. It's actually other consumer electronics. So you can apply the same principles, work in Shenzhen with the supply chain, build any consumer electronics.
Exactly. That's exactly right. And let's talk about the people who have left the company.
He didn't leave alone?
No, he didn't. He has an army who left with him. There were 4 other people who left DJI with Dr. Turbo. Number 1 comes Gao Xiufeng, we'll just call him Gao, the CTO of Bambu Lab, PhD in automation, another PhD. He actually graduated from the same undergrad with TAO Ye. So there is a chance that they know each other from way back. Mm-hmm. And he specialized in embedded software systems and AI. And to be honest, he is known as the person who is the largest product manager. He has the biggest ownership within Dr. Tao's scope.
Oh, he reports to Dr. Tao
directly.
In DJI.
Yes, on Mavic projects. So obviously you would take your number 1 with you.
Yes.
Sorry, DJI.
Oh, man.
Yeah.
It's a big hit, 5 people.
Yeah. And at DJI, he was the head of DJI System Engineering Department and leading R&D and technical solution design across multiple major product lines. He was known as effectively DJI's biggest internal project owner in that era. To start in Bambu Lab, he famously said one thing. 2020 was an era that 3D printer was essentially a no-brainer. It's just a motion platform. Users wanted to play with 3D printing, but ended up spending their time repairing and babysitting the machine. It's a pretty good thesis.
It's a pretty good summary of 2020.
Yeah, 2020. Second person, Liu Huaiyu, Liu, who later became COO of Bambu Lab. Software management background, and he used to work at Marvell Semiconductors. Oh, actually, Gao Xiufeng also had a brief time working at semiconductor industry. He was in Marvell for 6 years. So the two of them, shared a working relationship before. And in DJI, Liu Huaiyu, he was the product manager for DJI's FPV, first-person view product line, which is when your drone is flying, you can be holding a pad that shows, where your drone is going. It's basically the screen monitoring system. Mm-hmm. And he later became COO for Bambu Lab, the operations lead. Given his FPV and transmission background, and also this is just me assuming, it is reasonable to infer that, although not confirmed, that his DJI expertise around real-time video and data transmission systems could be used to help Bambu's camera monitoring and cloud connectivity.
That makes sense.
Yeah.
Yeah.
The next person is called Chen Zihan. He is the chief engineer and also known as the gimbal guy. And gimbal is the handheld pivot device that stabilizes the camera. And so he has a lot of deep expertise in motion control and active stabilization algorithms. That's it. And the last person is Wei. He is a senior engineer. He contributed a lot in DJI's Mavic Air 2. He's also a software system specialist. All right.
And I think he specializes in Lidar, which also is used in Bambu Labs.
Absolutely. So that's all 5 of them.
That's what that, wow. That's a lot of senior people that Dr. Tao took with them all together.
It's like everyone in the entire DJI for Mavic Pro.
Mavic is the
MVP product.
Exactly.
For DJI.
So DJI might have taken a pretty big hit back
Huge
then.
loss.
So when they targeted 3D printing after leaving DJI, what did the 3D printing landscape look like? Why were they so convinced that this was the industry to go? Like, what technologies do they use? Which stage were they at? Why did they pick a particular type of 3D printers that, extrudes plastic?
Right. And actually, out of Linda and me, Linda is actually a 3D printer owner. I'm not. But out of all I did go do some research on YouTube and learn the various types of 3D printing.
Please share.
There's like the machines.
I'm only like owner of one machine, so I think we'll rely the history part with you.
It is very interesting to study the brief commercial history of 3D printing. So let's start with that. There are 3 major types of 3D printing technology. Well, obviously with the technological development, there are a lot more right now. But for the ones that are fully commercialized and being used in different scenarios that has longer histories are 3 main ones. And the first one, so my suspicion is, did it start with military? However, the actual first ever 3D printer was created in the commercial space, and it was not military. In 1981, a Japanese researcher, his name is Dr. Hideo Kodama. Of course, there's always a Japanese researcher that started in the 80s, the prime time of Japanese research. Published a paper describing a layer-by-layer rapid prototyping system, but he never commercialized it until someone whose name is Charles Chuck Hull. He patent filed in 1984 stereolithography, SLA, and this guy is still alive. Basically, what SLA is curing liquid polymer resin layer by layer with UV light. And this technology is created mostly because of the frustration was real in Detroit's automakers, prototyping. What's the minimum amount of time that you could turn a CAD design into an actual physical prototype part? The fun fact is, actually in the early 2000s, I did take a CAD, computer aided design class, working in one of those computer labs, and you have to hand snap to grid. Then that took a really long time. Just think about that and it was way before that. I cannot possibly imagine how much time it took them. And SLA was used to fix that specific problem. It was a competition problem. Automotive prototyping speed in the 80s, US automakers were losing ground to the faster moving Japanese competitors, partly because turning a new dashboard bracket design into a physical test part took weeks, right? And SLA was the cure to that. And Chuck Hull, he commercialized that, and he also created a company which is called 3D System, which is going to come back later in this in the story. That company allowed engineers to print an overnight prototype for the automotive industry. The pros of it would be high resolution, a lot of detail, smooth, and you can achieve very fine features, like the smooth figures. The con of it would be parts are usually quite brittle. Liquid resin is messy and toxic, and it's weaker mechanically than the FDM parts that we're going to talk about later on. Number 2 started with military funding this time. As Cold War era defense R&D spending ramped up towards the end, agencies including DARPA, Office of Naval Research, Air Force, and NASA funded work on powder bed fusion method of 3D printing.
That sounds very complicated.
That technology, laser, became SLS, selective laser sintering. And it was developed fully in 1986 by Carl Deckard and Joseph Beeman at UT Austin. And later, that eventually became metal 3D printing. You can use various powders to consolidate that final printing product. And the military's interest specifically was to drive the logistics down. You're printing spare parts on demand near the battlefield instead of stockpiling and shipping them, which makes sense. And also remember, this goes back to the Cold War era, so that's why it was needed. And how it works is laser selectively fuses, or sinters. It's like heating but not fully melts the fine powder. And it could be plastic, it could be metal, layer by layer inside of a heated powder bed. It's like a heated powder cubic. And unfused powder around the parts stays in place and act as sort of a support structure. So it just stays like that. And once it's done, you can take it out, but it requires a little polishing and cleaning.
It's like if you imagine anthropologists digging up stuff from dirt and like brushing it off. That's how you dig up the SLS prints.
Exactly. Oh, that is very accurate. So the pros of it will be you don't need to have a support structure. It happens in a strong powder bed. It's very strong. It's durable. It's functioning. It's good for complex assembly, which is why I guess the military developed it in the first place. But the cons of it is also very obvious. It is very expensive, right? And the parts would have a grainy, a matte surface finish and requires more cosmetic polishing after everything if you want to be using it for different purposes. And powder handling requires equipment and safety precautions, so it's slower.
Not the most consumer friendly.
Not at all consumer friendly. And then the last one is called the FDM, which is the one that became more widely used later on. And it was a complete commercial and DIY story. It happened in a garage, of course. Scott Crump, an engineer, was trying to make a toy frog for his daughter, a toy anything.
So cute.
I know, it's really cute. In 1988, using a hot glue gun loaded with a mix of polyethylene and candle wax, which is a plastic materials of sorts, and extruding it layer by layer to build a shape. It worked well enough. I can't believe, like, who's like,
I want a dad
so
that
working.
built stuff for me when I was young.
He realized that, oh, this works, that he saw the commercial potential of it. And in 1989, him and his wife, Lisa, co-founded Stratasys and filed a patent for the process that we just talked about and trademarked it as fused deposition modeling, which is FDM. And later, competitors, when they develop similar technology, they cannot even call it FDM because they trademarked it. So the competitors have to call it FFF, which is fused filament fabrication. It's more or less the same thing. But
It's just something to prevent you from getting sued while the patent is still in place.
Exactly. So how it works is exactly what you think how it works. Thermoplastic filament, aka mostly plastic, heated to a melting point, and you extrude the melting plastic through a nozzle, depositing materials layer by layer onto a plate, and you're building a precision hot glue gun printing, and that's how it's invented. And back in 1992, a 3D modeler, which is Stratasys' first 3D printing commercial machine, was priced around $130K.
That's a lot of money.
Would not buy that. It is more expensive than a computer. A lot more expensive than a computer in 1992.
Yeah, back then it was not really for consumer use. Their target market was industrial.
Definitely. The pros of it would be cheap, fast. You cannot really hurt anybody with cheap plastics, and parts are generally, pretty tough, and it's easy to operate and maintain. The cons would be It is the lowest resolution of 3D printing of all, as you can tell. There's no precision that comes into that. It needs support. And historically, for whatever equipment that you use, that's going to be needing a lot of manual tuning and babysitting. The end of 1980s, mostly 3 separate technologies, all trying to solve one problem, which is why does prototyping take so long? And, well, the situation is most of these technologies were very patent locked and industrial only. So one thing on patent, FDM technology was under US patent. So like most countries, patent grants an inventor a fixed monopoly period in exchange for publicly disclosing exactly how this invention works. So you can patent it. You are the only person who are using it, but you just have to let everyone know that, oh, this is how I'm going to do it, which is melting plastic doesn't seem to be like...
So like transparency in exchange for protection.
For monopoly protection, exactly. And for US patent, that time in the 90s is 20 years. So in that 20 years, is non-negotiable, is not renewable. It doesn't depend on whether your invention succeed commercially or not at all. It's just a physical lock that starts ticking the day the application is filed and runs out in 20 years. Scott Crump filed FDM patent in 1989. So that put the expiration date on October 30th, 2009. And when the clock ran out, this patent will be released to the public domain. And when it released to the public domain, a couple things typically will happen. Number one, more people will be building this hardware, very likely, building and selling these machines.
Because you can build, but you can't sell before the patent expires, right?
There you go. Number one. Number two, once the hardware is in place, you therefore must need a software, or at least like an interfacing level that allows people to contribute more things onto it, right? Firmware designs, that community will be developed. And number three, as more people will be building hardware and having that interface level, there will just be a lot more people coming into the space and do things around it. It could be, SMB, small manufacturers, or it could be hobbyist kit sellers.
Yeah, and that's exactly what happened. So 5 years before the patent expired, even a bit before that, a lot of people had their eyes on this technology and they were literally waiting for it to expire. And like you said, they actually created the terminology FFF to avoid this clash while they develop based on top of this technology. So one thing that was really notable is a community group online that popped up in 2004, 5 years before the patent expiration. This is attributed to the growth of FDM as is today. This project is called the RepRap project, and it stands for Replicating Rapid Prototyper. So it's developed, or it started by a mechanical engineering lecturer at the University of Bath. His name is Dr. Adrian Boyer. Dr. Boyer's objective for this project is to produce a 3D printer that can print a significant portion of its own replacement part, which is where the replicating name, rep, in the RepRap projects starts from. And when you can reproduce yourself, that means you can make 3D printing cheap and available for everyone. And he wanted to do this because his university, and he was lucky enough that he's in the university where the university contributed to a fund that bought some high-end 3D printers that's worth 40 to 50K in one instance. And he mentioned that there's one that's actually $250,000. Yeah, and he was using this, but he thought it was life-changing. The first time you come across a 3D printer in the early 2000s. So he thought it was a massive breakthrough. He wanted to become cheaper and make it available for everyone. Super altruistic on starting this community. And he literally said it felt like a writer moving from using an old typewriter to a modern word processor. So he knew this technology was going to change the world, and he wanted it to be less expensive, and he doesn't want it to be in the hands of only corporate and large institutions. So he wrote this vision down, posted on University of Bath's website, and he also applied for a tiny grant, which is the smallest grant he's ever received, which is £27,000. And I think he did this on purpose because he was trying to prove that the grant that he needs to build this machine costs less than the cheapest machine that he bought or the university bought.
Yeah.
But then he didn't account. He mentioned he didn't account for the PhD student's salary that worked for him. But regardless, it's a university project, but a lot of people gravitated toward this project, hobbyists all over the world. And also, because the philosophy was to make 3D printing available for everyone, he decided that it made just no sense to patent any of the design that he published. So he intentionally released every blueprint under something called the open source GPL license. So this means everywhere, anywhere in the world could take and download his blueprints, even modify them, build on top of them, and not only use, but sell their own versions without royalties after the patent expires, obviously.
Right.
So it was all open source, university-based project, right? And that built the foundation of FDM printing as is today. Because his goal wasn't to make money. It was just, he wanted the conversation. This type of license can help a project go viral because you're almost supporting conversations, supporting people building on top of each other. And it did exactly that. So after he published his initial design in 2007, which is a printer called Darwin, and he named it after famous English biologist. So only 1 year after, someone in the RepRap community used this blueprint and successfully built his own Darwin and printed a working copy of itself.
Wow.
And this is 2008, right? 2008. The community then further developed over the years. By 2010, Dr. Boyer took some of the ideas and built the second version, an improved version of the Darwin. He called it Mendel, after another biologist, the father of modern genetics. And he picked these names because biology itself is the study of things that copy themselves.
Cute.
Yeah, I really like the name.
To replicate the lineage completely.
And so this version, the Mendel, actually became the direct ancestor of nearly every hobbyist printer that follows. And among those in this community was a young Czech contributor. His name is Josef Prusa.
Oh, that rings a bell.
Yeah.
Surely.
So if you do follow the 3D printing community, in actually true open source spirit, Josef Prusa took Dr. Boyer's Mendel design and he improved upon it over several iterations, in fact, and finally landed on a very popular machine called the Prusa i3, which he also then open sourced the blueprint in 2012. So he wasn't trying to make money, but because it's so popular among the community, it's often dubbed the Ford Model T of 3D printers. For 3 years followed, he sold a lot of parts to help others build their printers. And by this time, the patent that Stratasys owned have already expired. So also, other companies or other individuals downloaded his file, which is for free, and started sourcing materials on their own. And they could actually, with a very low cost, create their own product and sell them on the internet to other hobbyists around the world. And this gave way to the first group of 3D printing companies, a lot of them based in Shenzhen.
Wow. It's almost like a gray area, like the tricky time leading up to the patent expiration.
Right? It's tricky because Adrian Boer, for the sake of benefiting everyone, open sourced his project.
But it wasn't a university, it was nonprofit.
And as a result, other people build on top of it. And because of this open source license, anyone who wants to make a profit then can come in and make a profit.
and more people came in.
Right, of course, because they smell money.
So
And naturally, I mean,
opportunity,
you
yeah.
can't blame them. So a lot of companies were created. And so Joseph Prusa, who originally created this design, and he hasn't been monetizing it that much since he published it, thought, well, if other people are making money out of my designs, I should do this, right? He officially and finally decided to release what's called the original Prusa i3 kit. So he then sourced all the components put together in a kit and then started selling it in 2015, which is 3 years after he released the design.
Right.
And it was selling for 750-ish US dollars. So he started making these machines himself. And this is after a lot of people started selling them on the market already.
For sure.
Different versions of it.
Yeah, and I remember his name can be found on YouTube. There were a lot of 3D printing videos that's related to Prusa, and it's titled Prusa Research.
Yes.
Yes, that's right.
Yeah, because when he originally established Prusa Research, it was more kind of R&D, will publish more blueprints. It's only after around 2015 that he's really going, I'm going to commercialize this, and I should be.
Right. So besides the college journey, Prusa is kind of the OG in the 3D industry.
It is, yeah.
Got it.
And RepRap actually, there was a spin-off project called RepRap Pro that wanted to commercialize the same idea. Never kicked off as much as Prusa did in the end. And today, RepRap isn't really an active project anymore, as you can imagine. But what it actually left behind is the foundation of this entire desktop 3D printing industry that we still sit on, which, it's open source. It's based on the foundation that we want this to be in the hands of consumers and not a selected few corporates. If you're listening to the timeline, Bambu Lab is not here yet. Bambu Lab does not participate at all during this phase.
I mean, 2009, Dr. TAO isn't even in DJI yet.
Exactly. Yeah, so later on, I think Bambu also goes by a slightly different philosophy that ultimately, spoiler, clashed with this community.
Right.
Yeah. The second importance, which is, I think, less talked about, is the contribution of this RepRap community to popularizing the FFF or the FDM technology, because you mentioned there are 3 patents going on at the same time, all commercializable after expired. And obviously, the other 2 had other complications, but I think RepRap actually contributed a lot in making FDM, FFF the de facto one for consumer desktop printers.
At this point, if we were to look at the group of vintage, I guess, can I call them vintage 3D printers, aka those who developed in between the time 2009 to 2020, there are a couple of them who tried, but they more or less all ran into the same problem.
So at this point, actually, a lot of companies are trying to commercialize, right? Including Prusa, which we've mentioned, and also RepRap Pro, the commercial arm of RepRap, and a bunch of Chinese supplier turned printer brands. There's, at this point, also no patent protections. So why did it take 7 years for Bambu Lab to pop up? In reality, actually, a few of these companies were successful in those days' standards. So if you look at Prusa, right, they sold over 10,000 machines per month.
Wow.
And Creality, which is the Shenzhen-based startup, peaked around 870,000 in 2023.
That's a lot.
So they were selling, and just nothing at the scale of Bambu, because Bambu last year actually already reached 1.5 million units. So surpassing anyone in that era. And they were making a very good margin. So what drove this gap? We're talking about 2015 era. It's really not for your average consumer at all. You don't buy a 3D printer expecting it to work. In fact, you don't even buy printers. You buy something called the kit, and then you build it yourself. It's like assembling your own PC. The reliability is super low. There's actually a lot of factors that can destroy a print job. So one example, right? If you're millimeters off on the print bed leveling, your melted plastic is not going to stick to the bed, and that destroys everything, right? Or if that motor that moves around to eject melted plastic, somehow you like touched it and it's off by a millimeter, whole print destroyed.
Oh boy.
Right? So there are a lot of things that destroys prints. So you don't actually send your job to like today and come back like 10 hours or 5 hours later and you see like the finished product. So if you're interested,
I am.
Okay, there is a YouTube video.
Ooh.
It's actually titled 10 years ago, 3D printing was really hard.
Wow.
Straight to the point, is by the channel called Teaching Tech. There's so many things that can go wrong. And if you do fail, there's this, I really like the term. One of the type of failures is if you don't have anything to extrude on top of because something moved along the way, but the 3D printer will continue to move because it doesn't know something went wrong, right? Because there's no monitoring system back then. So then it keeps on printing and it just prints on air because there's no support anymore.
Wow.
And so the next day or a few hours later when you come back, you'll see something called
a beautiful mess.
A beautiful mess, and it's termed by the community spaghetti monsters.
Oh boy.
Which you can kind of visualize, right? And funny thing, in China, spaghetti monsters, and we don't eat spaghetti, obviously. So they're not called spaghetti
Noodle
monsters.
monsters.
They're called, exactly. They're called 炒面, which is
man.
fried noodles.
Fried noodle monster.
Yes, completely sidetracked. But the conclusion is nothing kicked off because it wasn't for the masses. It was for people who enjoy tinkering, enjoy building, and is willing to sacrifice time and effort to build something.
Definitely. So the reliability issue, and for I think a lot of the old users, and even for the users who wants to be taming 3D printers, it can be very intimidating.
Yeah.
This entry barrier quite high. You can not be able to assemble everything, and then you could have might as well generate spaghetti monsters
Exactly.
for the first batches, and it will be a waste of all of your filaments, which maybe not cheap.
Yeah. So during this time, actually, most of the headlines in 3D printing was actually in the industrial and medical use. If you ever come across news about 3D printing during this time, it's like we printed 3D prosthetics to help people with walking, and we printed 3D cells. We printed even houses. They did concrete 3D printing and on a very large scale, or 3D printed cars. Like Airbus has a 3D printing arm for rapid prototyping as well, and for replacement parts. So on the consumer end, all in all, it's not really in the forefront of 3D printing. There are actually, though, a couple of companies that made some headlines. Unfortunately, they eventually somehow died off. And so one of them is called MakerBot.
The biggest cautionary tale that everyone can learn from, which is kind of the poster child of 3D printing in many ways.
Yes.
It was founded, and of course, in 2009, rode right off of the patent expiration date and sold 40,000 printers before 2013. And Stratasys Incomes acquired MakerBot for, not cheap, $600 million US. And Stratasys' strategy was, if I can't be the patent holder of FDM anymore, then I'm going to buy the leader in FDM. So that's why they acquired MakerBot. And after the acquisition was made, they had one good year. 2014, it was the peak before it collapsed again, because MakerBot has shipped out the so-called smart extruder, which obviously entailed reliable, but ended up being catastrophically defective. The 3D printers were unusable for a lot of those who have received them. And it was so bad, there was a single back component that triggered this whole series of nightmare. A class action lawsuit against MakerBot / Stratasys was filed in July 2015, alleging that you companies concealed a known design flaw. You know this is not working, but you keep selling it. And as a result, CEO of MakerBot, Brett Pettis, which is a dude who looks incredibly like Steve Jobs in many ways, and who was also branded as the Steve Jobs of 3D printing. There was a video of him. He's kind of the artist, creator kind of style. He was ousted by the company completely. And later, his successor, Jenny Lawton, who also didn't solve this problem, was ousted. And there were mass layoffs, and manufacturing was completely outsourced to China. The closure of MakerBot retail stores was also done at around that time. The damage was so big that caused the parent company, which is Stratasys, having a 938 million quarterly losses just because of the acquisition of MakerBot.
Wow. They not only paid 600 million for them, they continue to pay 900 plus every quarter.
Yes. So
Wow.
it's not a good acquisition. And so by October 2015, MakerBot has to continuously lay off the staff member, and then more layoff and more layoff. So it was proved, at least for Stratasys, that this is for the hobbyist market isn't sustaining, and we tried, we didn't make it, we're just going to leave it as this. And that
Cut
was
your losses.
Yeah, and then that was MakerBot's experience. And another failed example, we mentioned 3D Systems before, right? It was a company filed by Chuck Hall, which is the SLA patent holder. He also tried, and he launched a company called Cube within 3D Systems in January 2012. And he did a bunch of things, also trying to recruit will.i.am as the chief creative officer in 2014. However, after trying to sell this to hobbyists, and he came to a very sad conclusion, which is this kind of thing, well, first it's a reliability thing. And if you want to solve that and continuously sell more machines, and then when the market isn't ready, there is no way to improve your profitability out of that.
Yeah.
So very quickly, he decided to exit that business. And then the consumer division of Cube was proved to be a money loser, and they dropped that business in total. And then there were a bunch of business who were like that. You probably also have a few other examples as well.
Yeah. So, well, I mean, one thing this whole influx of people trying to commercialize on consumer desktop printing actually helped drove the industry in China. Right? Because you mentioned how MakerBot ended up getting everything created and made in China. A lot of these parts are created in Shenzhen. So the whole, starting from the RepRap community, then to MakerBot, Cube, Prusa, everyone who entered, imagine where they're getting their print heads, their print beds, their circuit boards, their stepper motors. A lot of them will be in Shenzhen. And so the demand for supply has been just felt throughout Shenzhen. And some of the suppliers realize, hey, like I can sell you parts for minimum margin and then you make the profit. But then why don't I just put the printer together, slap my own logo, and then sell it direct to consumers, make that margin, and I can sell it for cheaper because I'm closer to the suppliers. So there's a bunch that kind of came up around that era in Shenzhen as well, and they compete on price, not exactly quality. And that's how, in general, China manufacturing in general, that's how it works, right? You start by copying, doing it cheaper, and then slowly you upgrade the quality. So, and they have the advantage of not relying heavily on R&D because of open source. The instruction and the blueprints are free to grab online. They can invest in some R&D to get a slight competitive advantage, and that's what some of them did. And at that time, the VCs in China are actually more than happy to pay because they also look at the picture and they see the combination of a high market ceiling, a recently expired patent, and cheap parts available in China. So all those combined, the VCs are like, take my money. Take my money. So within that period, a company called Creality was created in 2014, who was number one before Bambu got into the market, and they're currently still number two and recently IPO'd.
Can I just add, to be honest, I think for consumer electronics, the competitors are never overseas. It's usually the competitors back home. You always have to watch out for that. Like, for example, DJI Insta360 and so on and so forth. But yes, so Creality started 2014.
Because Chinese manufacturing, China is the hub of especially consumer electronics. So it's hard to compete on price, at least. Another company called Elegoo started in 2015. I hope I pronounced that right. Okay. Another company called Anycubic also started in 2015. And together, Creality, Elegoo, Anycubic, and Bambu are the top four that dominates the market today. 96% combined market share.
What about that
And
4%?
you're right. I think Prusa holds some of it. Okay. But you're right. They do need to compete in Shenzhen and not elsewhere. But even, right, with a head start, you ask, why didn't something kick off in 2015, 2016 when everyone got into this? So many money were put into this. Why did they have to wait for Bambu Lab in 2022?
To wait for a bigger competitor to show up and
Exactly.
compete with all
Like,
of them.
what happened during this time? So next, let's talk about how Bambu did it. And why did it take so long? So going back to the beginning of Bambu Lab's own story, in 2020 is when the 5 founders walked away from DJI.
Well, for the first 22 months of this company, it isn't all that exciting. And in fact, it's a little boring. And it also coincided with the time of COVID. So what's better than doing R&D during COVID time?
Because you can't leave the house.
There's not much of an option, right?
Yeah.
So it took in total about 22 months. And they just kept pouring more engineers on the project. It started with 5, and it quickly multiplied into at about 100 engineers. And those 100 engineers burn through 7 full prototype iterations by DJI engineering standard, and they run hundreds of physical tests. And yes, you guessed it right, they used up 3 metric tons of printing materials before anything can be allowed to ship. That is a lot of plastics.
High standards.
High standards. They will not make something that is not completable and not, I guess, frankly, perfect before they can figure out that this is new flagship of 3D printing. And then comes X1 and X1C.
Yeah, so they were in complete stealth mode, trying to kind of hide their development from everyone, actually.
Fun fact, it's very easy to hide during COVID time.
Which actually played to their advantage.
It's encouraged.
Right? So they finally broke stealth mode in May 2022 is when they launched the X1 series on Kickstarter. And Kickstarter is actually the forum where a lot of 3D printing companies launch their product. And so this is an unknown startup at the time, right? They were under stealth mode. Nobody knew about them. And they were promising super fast printing, high success rate. And they were using buzzwords on their Kickstarter campaign like AI, neural processing unit, automated calibration, just all those words thrown at users who've been waiting for something like this.
And when you were looking at it, you're like, is it really necessary to throw all of these words into one 3D printer? Let's see how it goes.
But they literally researched all the pain points and basically used those pain points to formulate their Kickstarter campaign message. And it worked, right? So for $1,000 to $1,500, they're selling this machine that they claim to be revolutionary. And Kickstarter has seen a dozen of revolutionary 3D printer campaigns that crashed and burned before.
Oh, definitely.
Yeah. So ultimately, what they're promising sounds so enticing that 5,575 backers rolled the dice that month and paid. The campaign actually raked over just about $7 billion during the span of only 1 month. And it's only the 3rd most successful 3D printing hardware campaigns at the time. So ironically, the second one was by Anker, another Chinese consumer electric company producing chargers, and they want to try their hands at 3D printing. That ultimately failed. That specific campaign ultimately failed. And 2 months later, in August, backers received their shipments. 2 months later. So this is why you're hypothesizing that this is just a marketing campaign, because typically how Kickstarter works is that you publish something and say, hey, we're prototyping, we're making it, please support us. And then you update on a regular basis saying that, oh, here's the newest prototype, here's the updates, we're developing it. You wait for a few months before you do the first shipment.
Right.
So what Bambu did is I developed everything, I actually created enough machine for the shipment, then I published it. Then I went out of stealth mode. And then immediately when I got the orders within that span of a month, I shipped those shipments. So it's all planned, right? And soon enough, as soon as the backers got their machine starting from August, an overwhelming amount of gadget reviews started populating on various places, mainly YouTube. And it just sent a shockwave throughout the entire industry. And if you go back to watch the early YouTube reviewers talking about X1, there's one thing that they echo over and over again is probably the main selling point, which is this machine was fast. It's not marginally fast. It's like 2 to 3 times faster. And that's a huge pain point for a lot of users back then. You wait for 5 hours for like something tiny to print.
Or like a spaghetti.
Yeah, or a spaghetti, and then you wait for another 5 hours to print another spaghetti monster.
Yeah. It must be really frustrating to see your 3D printer like spit spaghetti, and then there's no way for you to stop it effectively, and it burns your hand if you try to touch the nozzle, which you have had that experience. And so I think when people bought X1 and have it in their houses, maybe their expectations were quite low. So, if it crashes and burns, I won't be surprised.
Yeah.
But it didn't.
It didn't, for the most part. I mean, okay, just a caveat, as a Bambu owner, there's still crash and burns. But the rate of crash and burn is much lower than the, earlier 2022 other branded printers. And the opportunity cost is low because it prints fast, it fails fast. So anyways, there's 2 things I think that actually made the difference of why they're printing so fast. Remember you talked about one of the guys that left with Dr. TAO, whose name is Chen Zihan. He's the gimbal guy. So he actually leveraged his knowledge from DJI on how to stabilize cameras into the desktop 3D printing space. And he did that by using sensors to measure the mechanical vibration of rapid movements of the tool head. And then he would then use the motor that's actually already in the 3D printer to offset and actively cancel out that vibration.
Ooh, algorithm.
So minimize vibration from the printer by using what you already have, which is the motor.
It optimizes the output.
Right. And what they've done is they eliminated the printer from shaking so much when the print head goes faster, which allowed the print head to go faster, which allowed the print time to be faster.
Whoa. Positively reinforcing. Good engineer.
So taking something from DJI gimbal, completely turning it, applying it, somehow used existing parts that's on your machine anyways. It's just very clever.
Yeah, and it's who would have thought? Like the one thing that makes a huge difference in 3D printing was coming from a gimbal engineer.
Right.
Yeah.
And there's much more that they've used.
Of course.
So the second thing that helped the printer move faster is the clever use of conveyor belts. So at the time, pre-Bambu, the norm for 3D printer is to use 3 conveyor belts for each of the XYZ axes. So that resolved in a design we often call bed slingers. How it works is that the print head is attached to a horizontal bar that can move the print head left and right. So that horizontal bar with the conveyor belt moves it left and right. That bar then is attached to a rectangular frame most of the time. And that rectangular frame then allows the bar to move up and down. So you got the left-right movement, the x-axis movement, the up-down movement, which is the z or z-axis movement taken care of. But there's no front and back motion for the print head. And that had to be done by the print bed, the bottom layer that needs to take care of the front and back, which is why the print bed needs to sling front and back in those days. And you can imagine when you're trying to print and your base, your ground moves front and back, you can't print that fast.
You can't.
Yeah, because it shakes.
It feels like a grandma. Don't break.
Yeah. And so that's how it got the name bed slinger, because the print bed slings, right? And Bambu didn't want this for the X1 because they want the X1 to be flagship and they want it to be wowing everyone. So it can't use what everyone else is using in the industry. And so what they've adopted is something called the CoreXY mechanism. And I want to note that they didn't invent this. This, again, like everything else, is open sourced. And they just copied the design. And they can copy it because it's open source and there won't be any infringement issues. So the motor then in this design is now attached to a much more sophisticated conveyor belt system. So it's just not one way times 3, right? So if you're interested, I'm not going to explain the intricacies. If you're interested, this has a much longer conveyor belt system that allows the print head to move left, right, front, back, and diagonally. So it takes care of all the XY movements on a flat surface. So the bed doesn't need to sling front and back. What the bed only needs to do is go up and down. And if you think about, just envision how 3D printing works, the left, right, front, back actually moves a lot more because in each layer, your print head moves, right? The up-down movement is only once per layer and minimum movement of a few millimeters. So the Y movement is then attributed to the print bed, or that significantly contributed to lower vibration and lower likelihood of a print bed or printing failure. I hope that makes sense. If it doesn't, YouTube's there.
Video. Yeah.
YouTube is there. So on top of the speed improver, which is huge, right? They also did a couple of other things. One is they're practically plug and play. So going back to the DJI philosophy of, I want this machine to come out of a box and just print. There's a few setups, but pretty much plug and play. There's something called the automatic material system, which you no longer have to manage changing color halfway manually for a print. It just feeds the printer automatically and switch between filaments, which actually uses a very simple piece of technology called the RFID, which is, our badge to go into the office.
Right.
Yeah.
It just scans the different filament and understands which color, which texture it is, and then it would automatically pull that filament into the nozzle.
Down. Yeah.
Interesting.
Nothing, super fancy. Just
No
like
rocket
CoreXY, it's
yeah.
already there. They decided after so many rounds of testing that this is the best system. The other thing is also DJI adopted slightly. It's the LiDAR, the micro LiDAR. So in DJI, you're scanning surroundings for your drone. Here, you're scanning the surface of your first printed layer to make sure that it's smooth. And if it isn't, you pause the print.
Using LiDAR was a bit surprising for me because LiDAR in modern day technology all around us is typically in like geospatial analysis, autonomous driving, and all of that. And it is being on such a micro level on just a plate of 3D printing. Wouldn't have thought that they're actually applying like some really high level technology into one piece of well-designed machine. It's almost like designing 3D printing, but like robotics.
Yes.
Yeah, it feels that way.
Yeah, and something else they've added to the printer that's also a technology that existed. So they added a camera. And other printers have cameras too, but they added a camera and embedded kind of AI into it so that you can monitor your print. And if it doesn't look like what it should be printing out, also alerts the system. So a lot of it is actually software built as well after they managed to figure out the hardware. So all in all, it feels like if we're talking about it in hindsight, technology isn't that difficult, right? And that's why a lot of their competitors actually copied what they have. But to use that 2 years of stealth mode and understanding how they fit together and putting in a piece of machinery, they've managed to do what the entire industry of hundreds of companies wasn't able to figure out for the past 7-8 years. And that's what made the difference.
Yeah, so stitching everything effectively and delivering an 90%-ish ready product to the market. And it's very well designed. People can see that.
Yeah.
Yeah.
And I want to kind of read a blog post that Bambu posted earlier this year. When they sunsetted X1, but for a better version of the products. So they said in 2022, the desktop 3D printing was for the patient and the forgiving. Calibration before every print was a ritual, not a routine. It's very poetic. Hours spent tweaking parameters. The first layer was an act of faith, not creation. This is really funny. The market was dominated by bed slingers. CoreXY existed, but as an alternative. Multicolor printing was technically possible, but can stretch into a week-long project. Enclosed chambers were available, but only in machines costing thousands of dollars aimed at professionals. Bambu Lab packed all of this into a single device and priced it in a way that forced the entire high-end segment to rethink its strategy. Since X1, CoreXY has become the industry standard. Enclosed chambers have gone from luxury to expectation, and bamboo extruder design has been copied by competitors after competitors. And I really like this last sentence, which is, imitation is the sincerest form of flattery, and this 3D printing industry has never flattered anyone so unanimously. They are obviously publishing their own blog posts, so a lot of lights is put on the X1. In reality, this is what happened. X1 made a game changer device within an industry that have already been accustomed to slow and unreliable printers. And for that, they get rewarded in terms of market share and revenue.
And customer lifetime value and a lot of faith.
Exactly. So with that momentum, they didn't stop. They immediately start to build and release more product to capture even more of the market. So in November 2022, right after they shipped the X1, actually, they announced the P1P. So the P series, which is open frame, high-speed printer at a lower price point. And so the P series stripped out some things like side panels and color touchscreen, but it kept the main thing, which is speed. And quickly after that came around the entry-level A series, which is A1 and A1 Mini in September 2023, so about a year after P was released. The A1 Mini, which is their starter machine, launched at $299, which is kind of a genuinely impulse buy territory for someone who wants to try out a 3D printer but isn't really into tinkering, right? It's cheap enough so that you can be like, oh, maybe I'll try it out and see what's up. And that's what I did. So A1 and A1 Mini is what's been credit for a huge jump in their company revenue because the X1 targets OGs, people who have been in this industry and users, and they were trying to wow them and getting them to post on YouTube. P is somewhat also targeting people who have used 3D printing before. The A series is going after a completely new set of customers and therefore expanding the market to people like me who would otherwise not purchase a 3D printer.
They recently updated the H series, which is the super luxurious and professional ones for, I guess, the users if they want to upgrade, or for those who are into professional use who can just naturally upgrade into the H series.
Yeah. So before the H series, they actually paused for a year in product releases. So you'll notice that in 2024, they didn't release any new product. It was quite quiet when it comes to new launches. And H was actually published last year.
2025, yes.
Yeah, adding kind of laser cutting and drag knife cutting kind of capabilities. So what happened in 2024 is rather than pushing out more new products, they took a pause and they opened R&D centers in both Shenzhen and Shanghai. They also opened international branches like US, Europe, and Japan. And this is that year that Bambu just kind of stopped being a hot Chinese startup and just became a genuinely global company. And it's also that year that they surpassed Creality to become the #1 3D printer brand in terms of both market share by revenue and market share by units shipped.
Wow, interesting. In the year that you don't publish any new product, don't ship anything new, you become #1.
You make the sales. You deliver the sales. And I suspect there's a little bit of a manufacturing jam in terms of productivity or production capacity. I'm not sure if they completely anticipated the level of demand that they will get with the A1 release.
Right. I guess the only parallel that I can think of, well, two of them, with the publishing of, with the shipping of X and P and A and then to H, would be, well, there is Tesla. Tesla did ship out the Roadster first, which is the flagship of its kind. And then it tried to strip out of a few more expensive things and created a, mass friendly version, which is the Model S. And later on, they created the version with the cheaper battery options, which I guess could be the parallel of Series A. And I guess that's also in iPhone. You have the regular iPhone. Oh, and then you have the iPhone Pro, and then you have the Pro Max, and you have all of that. So it's kind of very similar hardware product design logic that they follow into, and it's very clear. So by the year 2025, they are the market leader. They're number one.
Yeah. And one thing I want to go back and note is that something else they did also, I think it's an amazing play, is 2023, they launched something called MakerWorld, which is a community that people can publish their models and can download, right? And by now, they claim that MakerWorld has crossed 10 million monthly active users.
That's a lot.
Yeah. And not only that, there's an 83% one-year retention rate. So for context, that's very unusual. That's very sticky for this kind of platform. For most content communities, you don't expect people to come back continuously during the first and even the second year of using it. You expect losing at least half of your community after a year. So 83% is nothing short of amazing. They do offer a lot of incentives that they pay out of their revenue for people to stay on it. But the amount of models, which is about 2.6 million as of end of last year, that's been posted on there for other people like me to download for free. And sometimes we can also click on something called Boost, and Bambu will pay the creator. Yeah. And so that number really jumps out. And that's one of the reasons. And I think that's actually a genuine competitive moat that they've created, because 3D printers can be challenged, and we will see how they are getting challenged right now. But having the community of 10 million people, it's hard to rebuild.
Right. Yeah, you're basically attracting all the capable creators to be on your platform first, and then they will continuously produce, and you'll reward them, and they will attract more people who want to use and download the models and recreate or just print out of their own laptop. And for that, I think the community itself, it really regenerates.
Yeah, it reinforces
the
hardware, and the hardware reinforces your community.
Yeah.
But it is worth remembering there's over 100 companies in China trying to get that piece of the pie.
So the competition within China is super fierce.
Yes. Even though Bambu is now the incumbent, as you can imagine, a lot of people would have their eyes on the pie. And remember, Bambu did grow this user base. So with a growing market and the fact that some of the technology we talked about is actually easily replicable.
You can imagine. Easily replicable.
Exactly.
It's all in the same village or the same factories. You can just go there and source.
Imagine, right? Someone saying that, hey, I want a piece of this pie. And one company, there's a lot of company targeting this area, but there's one company that actually made a bit of a dent last year that I do want to comment on. They're called Snapmaker. They're founded in Shenzhen in 2016, so during that era, and which is about 4 years before Bambu was even founded.
Kind of an older incumbent, previous incumbent,
And they actually did gain a pretty good reputation on Kickstarter, so they're a pretty decent 3D printing company. 2017, they launched a campaign on Kickstarter and another one on 2019. These two campaigns together raised $10 million, which is actually higher than the $7 million that Bambu raised for X1.
If I had met Linda way back and started Ascend in 2019, we would be making an episode on Snapmaker.
That's true. Because they did super well. 7 million on the second, right? So they had a hiatus after the 2019 release. They came back to Kickstarter in 2025 of August, so August of last year, with something called the U1. And this campaign raised over $20 million. So $20 million is 3 times of what Bambu X1 pulled in. And so the threat to Bambu that U1 created actually is that U1 managed to solve a long-standing pain point of Bambu users. So they kind of looked at the Bambu user forum and said, what could we solve and improve upon? And one of the things is multicolor printing. So I talked about how Bambu solved the automatic feeding, right? But at the same time, there's a lot of material and filament wastage with Bambu's version of multicolor printing, because in Bambu's machine, there's one nozzle. So when you change a color, you have to extrude everything from the first color, cut it, extrude, and then fill in the second color. But then you can't just print immediately because there's color mixing with a bit of melted plastic. So you waste some. So depending on what you're printing, sometimes you can waste more in terms of grams on a print than you actually produce. So you a lot of people are complaining about this. My personal experience is that I gave up on using Bambu for color printing because of the wastage. So I just do single color prints right now.
Right.
Snapmaker, being super smart, tackled this problem with 4 extruders. So each one of your filaments.
It's very intuitive.
Right? It's, again, a very simple way of solving this. But the trade-off is your machine needs to fit 4 extruders on the side.
True.
But because it solved this big pain point that Bambu has created for its users, a lot of people thought that this is, something I'm willing to contribute to, and therefore the $20 million raised. And that actually sent a round of panic within Bambu. And we believe it sent a round of panic because just 1 week later, after the Kickstarter initiated, on August 26th, Bambu published a blog post saying that, hey, you guys wait, it's coming. We're doing this. It's coming. Please wait. It's coming in November. And so they basically said, hey, we're releasing our next product. It's called the H2C. It has the different but similar technology, reducing waste. So if you're willing to stick around, maybe just don't purchase that and wait for our product. Wow. But it was a defensive move because they just released something a while ago. And so the smart way, if Snapmaker haven't released the U1, they would wait for a few months before the announcement, because that kind of cannibalizes your current product. So they were kind of caught off guard, and they published that, and it managed to help a little bit. But at the same time, U1 is $800, $900. The H2C, which is a product Bambu wants to release in the future, is $2,000. The difference is not because of the wastage part, is because H2C is actually the higher end product.
Right.
So it does other things like laser cutting that the Snapmaker
additional
doesn't.
Functions. It's not a stripped down version.
Right. But because Snapmaker took this advantage, they got free publicity through comparisons on YouTube of creators comparing the U1 and the H2C when they eventually released it.
And all of the companies that we've mentioned thus far are 3D printing companies who are in FDM. I think right now there are companies who will just, stand up and say, you know what? FDM seems to be pretty saturated. You guys doing what you're doing, we're going to do something else. So there are new companies doing other printing. So within FDM, all of the incumbents are likely within the names that we talked about, right?
Yeah. And funny you've mentioned that. We did not plan this transition at all. But you talked about resin printing, right? And how it wasn't so popular because slightly polluted. Toxic.
And UV light.
And there wasn't a resin printing equivalent in RepRap to make this type of printers more popular back in the days.
Because it wasn't a slicer style.
Yeah.
Right.
Yeah, it was a little bit more I guess, industrial if you
Yeah,
look
yeah,
at how
yeah,
the
yeah,
machine is made. But the technology is friendly for desktop 3D printing. So, and the quality of resin printing is very high.
True.
But one of the downside is that no one managed to really crack color printing.
Color resin printing. Ooh, that would be hard.
Exactly.
If it's liquid all dumped in one place, then it's liquid in one color.
Exactly.
And that's what Formlabs did, which is an MIT spin-off company that was created out of MIT Media Lab. But you were going to say someone cracked that problem.
Yes.
Oh.
And someone is called, and I'm going to, before I mention this someone, the technology itself is called inkjet printing or material jetting. Does that sound familiar?
That sounds like
Inkjet?
HP.
Right? Right. And HP exactly has this printer.
Oh, okay.
So the idea of inkjet printing, you probably already envisioned this, which is, you know how we have 2D color printers?
Yeah.
So instead of printing in ink, you just jet out thin layers of resin.
Oh, you color the surface?
You color the surface. And then, so it's like thicker than your 2D prints.
Okay.
And then you immediately put UV light on it to harden it. And then
doing
you,
like a coating layer.
Yes.
On a plastic thing.
It doesn't have to be plastic, so it
On
could just
any
be
surface.
a bed.
Gotcha.
And then you print a layer of color. The color is just like maybe
Pixel level.
Tiny thickness.
Gotcha.
Immediately harden it, and then print another layer, So the same idea as FDM in a way, but you do the inkjet.
Wow.
And this thing was actually patented. Obviously, because
Once
it's
again.
revolutionary. This thing was patented by a company called Objet. And Objet was later acquired by none other than Stratasys.
Of course.
Yes. And Stratasys, being the industrial powerhouse in 3D printing, they actually created and trademarked this technology under the term PolyJet. And PolyJet is a printer the size of my bathtub.
Wow.
Yeah, and it costs tens and thousands of dollars. And so naturally, there's no machine really released on the consumer front. But this patent expired a few years ago, right around when Bambu Lab started. And if someone can make this a consumer-friendly product, they could probably revolutionize 3D printing just as how Bambu did it for FDM, right?
Absolutely.
Because this thing, you can imagine, is a game changer.
It has color.
Yeah. And guess what? And it's not only color in terms of like bamboo 4 filaments at a time. It's every color on the spectrum kind of color. And just last month, and it's great that we're recording this today, just last month, a startup called HeyGears launched the desktop version.
Ooh.
Yes, on Kickstarter. Kickstarter is where everyone launches their printer nowadays. And I checked this morning because the Kickstarter is still ongoing, and I'm actually sincerely thinking about getting one of these.
Yeah, well, yeah.
If
you notice that Linda is really like, if she's checking something more than 2 times, that means she wants to buy it.
I know. But please stop me. It costs like $3,000. There's still 29 more days to go in the campaign. Now they have about 3,000 backers already. And because the average price is much higher, it's $12.5 million generated.
Wow.
So legit competition, right? But we don't know. There's a handful of videos on YouTube of people who have already received the pre-release version. But there's not that much kind of reviews about how this printer is. But I'm feeling positive based on the reviews, but also knowing that the reviews are likely paid for by HeyGears. So, Bambu, as a conclusion, not only have to watch their back from Creality, Anycubic, and Elegoo. This is the time we mentioned that Elegoo is now backed by DJI. Do you want to? It's interesting how your former employer, which you walked out, now backs your competitor.
Well, there was only one thing that I wanted to add about Elegoo and why DJI has to back it in 2025, and it was November. So TAO Ye posted a very long sort of piece on his WeChat moments, which is kind of like the Twitter, and then we all check and talking about his former employer and criticizing Wang Tao Frank, which is the founder of DJI, and he was basically explaining why Elegoo was competing unfairly because like in the contract it has a lot of clauses that was kind of targeting Bambu Lab. And he was saying that this is the right way of competing. And he was quoting something that Frank Wang said before Dr. Tao has left DJI. And Frank famously said that, oh, you can't let your competitor get the money and compete in the product and the talent with you. That will be the biggest trouble. That was when Dr. Tao was still in DJI. And because DJI didn't want to start 3D printing, so that's why he had to leave, and Dr. Tao became the biggest competitor, and now he's looking back and saying, well, if you had me working on this project within DJI, maybe, you know, like this would have you could have had this, but now you're doing this in the wrong way. Anyways, so kind of goes way back. So these two people probably, you know, have some beef, but
a bit of bad blood between the two.
A bit of bad blood, but which kind of makes sense why, you know, DJI has to go back and fund Elegoo. Yeah, and with DJI engineering, we shall see how this competition will turn out. It is still very fierce, but so far all in the FDM segment.
Right. But also, I guess what I was trying to say earlier is that not only do they have to defend themselves in FDM, there's kind of raisin technologies popping up everywhere. So HeyGears is one. Actually, a lot of their Chinese competitors, their Shenzhen competitors, are dual channel. So they also develop both FDM and resin printing, 3D printers. And Bambu, because they're so, maybe they've added R&D effort, but they're very much concentrated on FDM right now. It's kind of difficult for us to really conclude that they've won the market, right? Because they're just a market leader during the time when the technology is moving from targeting a small group of people, niche, to a wider population, and generally is kind of uncomfortable because a lot of research are going on the side. So there's if you look up something called volumetric printing, that's also in the resin space, still academic paper stage, but could also fundamentally change how this works because it basically shines the UV light and make everything all at once instead of layer by layer. So imagine the speed improvement there.
Oh, it's basically magic.
Pretty much.
Shines a UV light upon everything and it's formed.
And then it's there.
Yeah. We're one step close to magic. Like that's what we know.
Yeah, and this is, it's always research, patent, commercialization.
Yeah. Well, now we also know that the speed of prototyping is increasingly faster.
Thanks to 3D printers. Yeah, so with all of these, right, they actually, before Bambu started asking for money, so their initial investor, IDG, actually wanted to invest more, but Bambu's like, no, we got cash, we're good. So they stopped getting new rounds of investment after 2023. But with this new kind of competition going on and trying to fend off their incumbent position, there's rumors only, that they are partnering with Tencent and there might be some investment coming from Tencent. So kind of going back to what this means, right, in terms of let's give our audience a flow of the revenue since they've started. 2022, their first shipment, 5,000 on Kickstarter, probably another 5,000-ish after Kickstarter. So 10,000 units, $15 million, right? 2023, the P series and A series shipped, that went up to $300 million. So multiplies. 2024 didn't ship anything, but tripled their revenue. I mean, didn't release anything, but tripled their revenue to $800 million. Last year, 2025, shipped the H series and roughly doubled in revenue, about $1.5 billion, equating to 35% to 43% of the market, depending on which report you're looking at, shipped over 1.5 million units, which is 150 times the first year, which is only like 4 years ago. We can comfortably say they've ascended.
Yeah, with that speed of shipping hardware products and not having any major missed deadlines or major delays or major complaints about hardware being put into users' hands.
Right.
Pretty impressive.
Pretty impressive. And at this point, the valuation is multi-billion dollars. So, but there's always a but. With any company that grows in this speed, there's bound to be mishaps and controversies.
Oh, a lot of lawsuits.
So we do have a section on that as well.
Yeah. They grow so fast, and then they have so many mishaps that we have to designate an entire chapter onto the mishaps, because that's just the level of conditions that they're experiencing. All right. So there are 4 types of mishaps or issues. Number 1 would be, well, once again, reliability issue. They're a good design doesn't mean they don't have any reliability issue. Number 2 would be IP infringement, because of course they always run into that kind of problems. Number 3, fighting with the aging incumbent. Stratasys is always there somehow in the story. And number 4, the dispute on open source.
Fighting with the community.
Fighting with the community. So let's start with the defects, shall we?
Let's do that. So 2 defects that I managed to dig up, and I think a lot of hardware companies have these, and I think they resolved this pretty well. The first one is in 2023, so 1 year after release, the X1. It's basically when you send your job to a printer and the printer isn't plugged in properly, it doesn't print immediately, right? But when it receives it prints like 10 jobs at once because you kept on sending the jobs because you thought it didn't print. So this is exactly what happened to Bambu. User, because they use this cloud connectivity, so when you send a job from your computer, it goes to Bambu Cloud, then it goes to your machine. And it got stuck in the cloud for a while. And then users are like, what's happening? I'll send a new job. So one day, August 15th, midnight, US time, everything started printing while you're sleeping. So, I mean, yes, mishap, like awful, but
that
can be
pretty creepy.
Yeah, it's a bit creepy, but not life-threatening. It's still a good machine. People got over it. Second thing, and I think they managed this pretty well, which is the A1 recall. So after they released A1, which is their entry-level printer, they realized the cables that are connecting the printer to the wall is not super prone to heat and damage. And they claim that they did a lot of they have QA, right, while they're developing the product, and they did a bunch of tests to make sure it's safe. But somehow they missed the fact that when a machine is in transit, there's a lot of damage done to where you connect the cable, and somehow they missed this. And because of how people place their printers at their homes, if it's really against the wall, it's easy for the heat to develop, and there's a fire hazard. So they had to recall this. And they did it cost them millions of dollars, but they did it in a manner that the community was like, okay, like I got my refund, or I got a way of fixing it. So everyone was fairly happy in the end. So the defects are, yes, mishaps, but not life-threatening. The next one is the most fun one. It is Pop Mart sued Bambu Lab. Oh, Labubus.
I know, because of Labubus, because
course.
of the knockoffs. Yeah. And of course, Labubu 3D models are being uploaded to MakerWorld, and people were trying to print it out illegally. When you print it out, when you create a model just on your own, it's not illegal. But when you're trying to distribute it, and that becomes a YouTube or a YouTube/Napster problem, right? You as a platform is responsible for what your users upload question. So it didn't have to get resolved by trial. It was kind of pulled back. But the resolution is Bambu basically pulled all the offending Labubu files aside, and it was finally settled mid-March 2026. The policy became, if there is any Labubu that is being uploaded to Bambu, we're going to pull it out.
But it's interesting because I'm on MakerWorld a lot these days. I don't see Labubus, yes, but I see Marios, I see Pokemons.
I know. Which is, Labubu isn't the only IP that was being uploaded. There's Ultraman, there's Detective Conan. There are a lot of IP still being uploaded to that, but it's just Pop Mart had a problem with that because Labubu was kind of its MVP in the year 2024 and 2025. It didn't want it to impact sales. And Bambu wasn't the only company that have IP infringement issues. MakerWorld's Labubu, it's Thingy versus Yoda problem. It is Prusa's Lego problem. So every player before had a similar IP problem. But this, obviously, you can always use at least your legal policies to say that like certain IPs should be pulled off.
Yeah.
Right. If you're not using it for proper uses, or if you're using it for commercial uses, at least you should get licensed to do that. But to be very honest, I think some of the Labubu designs are quite cute.
They are really cute.
They're really cute.
Actually,
but it is a problem.
Yeah, but this calls into a bigger question, right? So at some point in the future, I can imagine where a lot more people owns a 3D printer. And so if I print at home a Labubu that I've designed, is that IP infringement? I'm not the IP infringement expert, but because you're giving the ability to design, the capability to design to the masses, these kind of problems will continue, right?
So maybe there is on the firmware that they're able to track it. If you were to just print one thing, because it all has to go through Bambu Connect, right? If you were to just print out one, they would know, oh, you printed out one. But if you were to replicate it, 1,000 of them, maybe they would have a question was, why would you have to print out so many of the same copy, right? You know, so I think that's probably why they have to install this level of firmware to be able to know that what are you actually using your firmware. And Thingiverse and, you know, all the previous vintage versions, they will have similar problems.
Yeah.
It's impossible to avoid, but you know, everyone is doing something. Is it perfect? Not, it's not.
Yes.
Yeah. People will do what they have to do.
Yes.
Okay.
Imagine how people will be upset if Bambu Labs closed down my printer because I was printing out more Labubus. But we'll get back to that in a bit.
Get back to that.
The next lawsuit.
The next lawsuit is Stratasys is fighting with the aging incumbent. In short, Stratasys sued Bambu Lab greatly. What is actually being claimed, 10 patents across 5 different areas, including purge towers, general extrusion-based layer deposition, tool head force detection, a bunch of different technologies. And then there are 2 parallel legal tracks. 2 things are being put in place. One is a standard district court case. That is just seeing financial damages and seeing an injunction, and usually takes a little longer time. It's pretty standard in the US. And the other one is interesting. The other one is a separate ITC, International Trade Commission complaint under Section 337 of the Tariff Act. And this is the more consequential one for Bambu. The ITC has the power to issue an exclusion order blocking Bambu Lab printers from being imported into the US at all. And and ITC proceedings typically moves faster than the US local district court cases. So this mechanism behind, and then this is why Bambu Labs actually make the headlines in a lot of the US news, is because of the ITC suing.
So there's a future where you can buy a Bambu Lab anything in the US.
Well, you think about this, DJI is on the entity list. So whether Bambu Lab can actually make it through ITC, you have to wait and see.
That rhymes.
But you know what? I think 3D printers in general would share similar risks. So if you were to ban one, you might as well ban all of them.
Yeah, I think
right?
Stratasys just targets Bambu because it's the biggest.
Right.
But there's also a scenario where Bambu kind of, for example, purge towers, if you say I can't use it, I'll develop my own alternative
purge
version.
towers. Yeah, exactly. And just file a US patent. So obviously there are workarounds, but currently I think Stratasys is wildly unhappy with the fact that Bambu is, number one in terms of commercial sales.
Which is interesting because Stratasys kind of left consumer space.
Well, but obviously still wants to get the money.
Yes. We'll wait and see for this one.
Yeah.
The final one is actually Bambu against the community that created 3D printing.
Ooh,
this is
the messiest one.
It's a bit messy. It's a bit bigger. But before I go into this issue, I do need to explain one piece of vocabulary, which is what is a slicer. In 3D printing, you can't just make a model out of your AutoCAD software or any of the 3D printing software and expect the printer to understand what's going on. There's actually another software called the slicer, which translates the shape of your 3D model into instructions, like where does the machine need to move, how much to extrude, how thick each layer is. And that's what is called a slicer. And it basically slices the model into horizontal layers and then writes this path for the prints to follow. And here's why it matters in our story, because this whole process is fairly standard today because and thanks to the open source community that we talked about earlier. So in 2011, someone named Alessandro Renelucci released a slicer software called Slicer with the 3, so C3R instead of CER. And this is released under the open license AGPL, which means free to copy, free to modify, you can even sell it. In 2016, this is when Prusa, after Prusa released the i3 kit, Prusa actually forked, which means built on top of the slicer, and made it and published it under Prusa Slicer, the name, and it's supposed to work better with the Prusa models. Furthermore, in 2022, Bambu Lab forked Prusa Slicer and made it into Bambu Studio. So it's like, you know, you have parents and then you have child, you have grandchild, and etc.
Different generations.
Different
of slicers
generations
forked on top of the previous one.
Exactly. And a lot of the functionalities are the same, but what Bambu Studio built on top of Prusa Slicer is something called like connectivity network. So it connects to their cloud. It also recognizes the RFID tag of the bamboo filaments. So you kind of build on top of it, but fundamentally it's the same thing, right? So in 2022, another developer actually forked Bambu Studio.
Ooh,
yeah.
Who is this person?
And he goes by the name Soft Fever. We don't know his actual name, but he created the OrcaSlicer, and OrcaSlicer works with any printer brand, which is why it's really popular. And it allows people who enjoy tinkering to play around a bit more than the Bambu Studio. Right, so it quickly became very popular, and back then you can send anything from OrcaSlicer to a Bambu printer without any issues. But that went on for 3 years, and Bambu decided to change that, which started this whole mess.
Wow.
So in January 2025, Bambu basically said, we're going to ship a firmware. They didn't say we're going to cut off OrcaSlicer. They said we're going to ship a firmware update, and it includes authorization control, which blocks third-party slicers from talking directly to our cloud and the printer. So remember how it works is from a slicer software, I have to send my job to Bambu Cloud, and then Bambu Cloud sends it to my printer. So it's not just computer to printer, even though they're in the same room.
Right.
So Bambu blocked the cloud access, which prevents cloud from sending the job to printer. And you can imagine how angry people are because they've lived on open source this entire time. The whole philosophy was built on what Dr. Boyer built with RepRap. And so Bambu was like, okay, we did this for your security and for our security. And they cited that roughly 30 million unauthorized server requests. They're saying a lot of people are trying to attack their cloud in that sense. That's why I have to block it.
Attack the cloud.
Like try to send jobs.
Using your cloud to to link your cloud to something else that they actually use to print the job.
Yeah. So they're saying that we did this to prevent other people from hacking our cloud to print on your printer, which is, I don't know. There's so many ways to protect people from accessing your cloud, like an API key. You know, that's not, people didn't buy into that reason, let's just say. But to their credit, Bambu didn't really shut the door. They offered 2 workarounds. So the first one is developer mode. So you can actually turn on developer mode on your printer that bypasses the cloud. So I can send directly in my room laptop to printer.
Right.
But then that bypasses the cloud, meaning all the cloud functionalities are gone, which means I can't monitor live what my printing is doing.
Well, just basic. They're
some basic stuff. But like there's some grumbles with the users that bought their machines. But it didn't turn into a life-altering decision. Like they didn't burn their Bambu products because of this. So on YouTube, a lot of people posted workarounds. They also offered OrcaSlicers to probably change their program to then enable them to send to Bambu Cloud.
Yeah.
OrcaSlicer declined because they didn't want to do that. So that all went well until April 2026, when a developer named Paweł Jarzak released a new fork of OrcaSlicer. And this new fork did one thing, which is restoring cloud access to Bambu. And he did this because he kind of hacked what Bambu published in their Bambu Studio slicer. Remember, Bambu Studio, the slicer program from Bambu, is open source because they got it from Prusa Slicer, which is also open source. They had to publish it, which gave all the developer access to their code. So if you read the code carefully enough, you'll figure out a way to hack it. And so he figured out a way, this developer, Jarzak. He figured out a way, published it as he should with open source licensing. So he gave everyone this new OrcaSlicer that restored access. And it could have all ended here, but Bambu decided to call their lawyers. Ooh. Bambu sent him a cease and desist, and they alleged that he was trying to impersonate their app and illegally reverse engineering their app. So Jarzak, being an independent developer, actually took the code down, but he didn't do it really quietly. He defended by publishing his own case on GitHub. And I know. I mean, you can't expect him. And then the
fire starts to burn.
And that's when everything started to burn, because he claims that Bambu Studio is licensed under AGPL, right, which inherits from Prusa. And that requires that when you build something on top of it, you release everything. And he claims that Bambu Studio didn't release anything because when Bambu published Bambu Studio, there's this plugin that connects to the cloud. They didn't release the plugin code.
Wow.
So he counterattacked, saying that Bambu should have released this cloud connector in the first place.
But you did not do your duty in the open source community.
Exactly.
You failed.
And that upsetted everyone who participated in that open source community. And it brought awareness to people who are fighting for open source for the consumers, namely Gamers Nexus, which is a major respective hardware outlet. They published a piece literally titled, and I'm sorry for swearing, Bambu Lab. And they rehosted Jarzak's code because Jarzak didn't actually want this whole lawsuit to fall upon him. He took down the code, and they not only rehosted the code, they pledged $10,000 in legal defense fund if Bambu gets sued for this. Another guy whose name is Louis Rotman, he's on YouTube, Right to Repair Advocate, pledged another $10,000, and I've seen already 3 videos of him attacking Bambu based on this. Right, so this made a lot of news. Interestingly, remember Snapmaker, U1? Yeah. They send Jarzak their hardware to support him. Wow. It's like taking a bite out of your competitor while you can, right? So a few days later, this got even more pumped up because the nonprofit that published the AGPL licensing, it's called Software Freedom Conservancy, SFC. They decided that it's time that they stepped in and opened an investigation on Bambu. And they ruled pretty decisively. Jarzak did nothing wrong. Bambu, you've been out of compliance for 4 years. Ever since you published Bambu Studio, you shouldn't have bundled something closed source, which is your network plugin, into an otherwise open source software that you got from Prusa. And so this is where we stand now. And not only did Software Freedom Conservancy said, Bambu, you're wrong, they actually decided to launch a fundraiser targeting $250,000 to hire legal counsel.
That's the Baotobu project, right?
Yes, yes. And so this project ended up raising more than this amount that they set out. And they're going to do a couple of things. One is they'll hire legal counsel to probably sue Bambu Labs in the future.
And guard the open source community.
Exactly. And guard the freedom for people who buy machines to own their machinery. They also put together a team to crack that closed piece of software. So they're going to reverse engineer. They hired engineers to reverse engineering the network plugin, because rather than going through legal battles, which we know can be very time consuming, if we just open source your closed source software and published out there and really just screw you, it's much easier.
We'll just open source you whether you like it or not.
Yes. I don't know who thought of this, but
it's crazy.
Yeah, and Yarzak was part of that committee. He's been asked to join the committee to hold not only Bambu Lab, but the 3D printing industry in general on accountable
for open source, for truly being open source.
Exactly. And that's where Bambu Lab stands right now.
They're complicated waters to navigate through right now. Yeah.
This comes with, growing so big so quickly.
Yeah.
I'm sure they would have expected it.
Well, now they have to put a lot of attention on it.
Yeah, it's just ironic. They could have stopped it by not issuing
the cease and desist. Wrong move.
But regardless, I mean, they're still number one in the world.
Still very impressive. Still a pretty excellent company in hardware making.
Yeah.
And we both liked that it was definitely started by a group of makers, hardcore engineers who wanted to start something else, who wanted to build something from scratch, not just doing the repetitive engineering work. And I think that brings us to the last segment of why do you think they've ascended?
Yeah, there's so many things, but I think the main thing is just listen to the consumers and trying to tackle problems and having the faith that they can. Because I saw an interview from the team where they said, are there any instances where you think this could fail? And they said, no, because when we looked at 3D printing back when we started this project, it was pretty clear to us that the hardware can be improved to the extent that consumers will end up adopting and liking it.
When I did the research on DJI and understanding the hardware business, a couple metrics really stood out to me. And well, obviously, number one being your growth and your skill, being sustainable as a consumer electronics. Profitability and efficiency. Once again, if you're consumer electronics, you may not be the most efficient because your need is varying all the time. Consumers always have new demand. And the next one is ecosystem and platform health.
Yes.
And specifically, there is a rate that is called attach rate, which is the consumables or the accessories revenue per hardware unit sold. Ooh, they've done pretty well in that.
Oh, really?
Yeah, they're the attach rate. And platform engagement, the MAU and DAU, the software bit, the community bit of every hardware sales. And I think for Western companies like Whoop or even Garmin, the model that they pick is usually a software subscription bit. But in China, people don't usually pay for a software subscription. They like the free software, the free community, but they will pay for the thing that they get in their hand. So I think that really made it what Bambu Lab is today. And finally, if you have done all three things above right, it should manifest in your capital and valuation. Right?
And it did.
You should grow fast. And yeah, so to be honest, in terms of every single bit of the metrics that we've just talked about, profitability and efficiency, the ecosystem health, valuation, you just tackled everything. And on top of that, there is the brief discussion on the flagship product, right? There are the better flagships and there are the terrible flagships or the product that they've created. The good flagships would really understand the current users' problems and try to solve that.
That's exactly what they did.
That's all you have to do. It's not necessarily a cheaper one, and it's not necessarily creating a problem out of nowhere and just pretend that's the most important problem. That's not it. Don't be arrogant.
Yeah.
Be very down to earth. Do your research and understanding where people are actually stuck on these days. So that's exactly what they have done.
Yeah, and I think the success of their first Kickstarter and X1 is what ultimately brought them everything that followed. So imagine if they didn't do that correctly, then whatever that's followed might not be here today.
Yeah, it is being very humble, right? And actually made an excellent product with DJI level of engineering and the obsession of, I just really want to make the consumer take it out within 1 second, plug it in and start to use it. So that philosophy worked once again.
Yeah. And I think lastly, also on my end, despite the controversies we talked about, right, they're actually really good product builders in the end.
For sure.
And so regardless of what ultimately happens with all the controversies, if they manage to continue to develop good products, we see how they've managed to use the A1 to expand their user base. The people that are upsetting today are the older users who adopted Bambu or who adopted 3D printing when it was predominantly open sourced. I personally, I'm a newer adopter that came into the scenes because Bambu has made it cheap enough for me to buy something. And there's going to be users after me that decided to try only because Bambu has made it feasible. And so they didn't quite, I'm not the target audience for OrcaSlicer. I don't have the capabilities to do that. And so I think for them, yes, it's not ideal when you're fighting against the community that has kind of enabled you in the first place. But commercially, I actually don't see that much of a damage if they manage to continue to churn out good products because they've decided on the Apple closed source system path.
Well, also think about this. If there is any company in the 3D printing in general that is going to, offense and someone has to take one for the team. And that someone, 100%, is going to be a Chinese company.
It is going to be the company that's the heads up everything.
Right? Exactly.
Yeah.
So there you go. Like whoever is more capable will be the first one who will take the hit and will have to solve it. So I'm sure,
they will face more problems in the future.
They'll face more problems in the future. That's what if you grow the fastest, you will also have to solve the problems first. So we shall see. Well, once again, this is a rapidly changing industry. A couple years ago, it was Snapmaker, right? And then it was Creality, and now it is Bambu Lab. So who knows in 2-3 years, who will be the leader in this game? All right.
Okay, so I'm looking forward to reviewing this in our maybe December special series to see how much things have changed in 6 months.
Yes, we will see how it all goes in the next couple of months, and I wish them the best of luck, and then I honestly see them having a better relationship with the open source community.
Yeah. Thank you everyone for listening.
Last bit, an apology for recording this episode so late, and as you can hear, my voice is not in the best shape, and I've been sick for a while now, so sorry guys for updating very late. And Linda and I, we have both put in a lot of effort in this, but I think in the next episode I shall be fully recovered. Thank you again.